Bismillahirrahmanirrahim. Sophia Suhail is here. In this topic, specifically, I will explain the series expansion of the function in the topic of the differentiation. Okay, so how we are doing it and why we are using it. Okay, so let's start that one. As we know that a series of the form a naught plus a1x plus a2x square plus a3x3 plus a4x4 plus continuation until the any general term plus that one, okay, any nth term, that is called, it is called the power series. Power series expansion of a function f of x. This is the power series expansion of a function f of x, where these are the coefficients and these are the variables. Okay, these are coefficients a naught, a1, a2, a3, a4 are the coefficients, and x squared, x3, x4 are the variables up to xn. Okay, so if we want to determine the coefficients to specify the power series, so we will find out that by finding the successive derivative of this power series and evaluating all of that derivatives at the x equal 0. Okay, so let's start this one. First function is, we have that, let me write that statement also for your convenience so you can better understand that. Okay, I write that we determine the coefficients, all these coefficients to specify the power series by finding the, we want to specify the power series by finding the successive derivatives of this power series and evaluating them at x is equals to 0. This is the same statement which I speak before, and then I write that one. So let's start with that. Our function which we have supposed, that one is there, a naught plus a1x plus a2x square plus a3x cube plus so on. Okay, let me write down the few terms only. As I will go on, I will continue writing the other terms also. a4x4 up to that one. Okay, so if I want to find out, okay, the its value is at, if I put its value at f0, it will become only constant number. Okay, means if I am putting x0, these all terms which are having this variable, they all will become 0, so only the constant term will left. Okay, now I will take the first derivative of this function. First derivative means the constant term will be finished because the derivative of the constant term is 0, so this term will become 0. Derivative will start from this one, coefficient of a1, and derivative of x will be 1. So I am not going to write that one as 1, plus a2, its power will be written in the start. X plus 3 will be written in the start, a3, and power reduced by 1 square, plus 4 will be written in the start, a4, and power reduced by 1, that is becoming 3, and plus so on. And now it's the same, if the same function I am looking for the value of x is 0, so f bar of x will give me, x0 will give me, first derivative at 0 will give me only this function a1, because remaining all will have x variable, that will turns to 0. Now second derivative, in the second derivative this constant term will be 0. Okay, so which term will left, that is the first term 2a2, x will become 1, so I am not going to write that one also, plus 3a3 2, this power will come in the start. Okay, so it will be 2 times 3, or you can write like this, a3 x Power reduced by 1, it will become power 1 plus 3 times 4 a4, power reduced by 1, it will become square, and plus so on. Okay, so when I'm writing this function, I'm taking at x0, so it will turns to f second derivative. At 0 will give you only the variable, all the variable will become 0, the term with the variable will become 0, only the first term will left, that is 2a2. Going in this way, I'm taking the third derivative. Third derivative will make this term 0 because it's a constant term. So first term will be this one, that you can write it as it is also, or that you can write in the form of 6 also. I will suggest write it as it is. 2 times 3 a3, x will become 1, derivative of x will become 1, plus this will come in the start, 2 times 3 times 4 a4, and derivative of x square will be x, because it's power written in the start by the power rule, and power decreased by 1, 2 minus 1 is 1, and plus so on. Okay, now its derivative, when I will take its value at 0, putting x0 will make this function also 0 and successive remaining function also 0. So its value will become f third derivative at 0, that is only giving you 2 times 3 and coefficient of a3. Okay, going in this way, I didn't write that one term, but I can suppose that what it can be, fourth derivative. Now this term will be constant, without x this will be 0, and this will be the first term. Okay, means 2 times 3 times 4 a4, x will be 1. So what will be its next term? Its next term will be, the power will be was written in the start, so its power was 5. So first fifth power will come in the start, then first derivative fourth power will come in the start, then third power was coming in the start, and then second power was coming in the start. Okay, so variable will be 1. Continue in this way. Now this derivative, when I will find out its value putting x is equal to 0, so all the terms with x0 will become 0, only this constant term will left as it is. Okay, so I will write that fourth derivative at 0 will give you answer 2 times 3 times 4a4. Okay, now we get all the successive derivatives at the value of x is 0. From here, if we want to find out a first coefficient, that is equals to f of 0. From here, second coefficient a1, that is equals to f bar of 0. From here, a2, third coefficient a2, that is equals to f double bar of 0 over 2. From here, this will be equals to f triple bar of 0 over 2 times 3, and this will be equals to a4, that is f fourth derivative of 0 over 2 times 3 times 4. If you remember, so 2 times 3 we can call it, 2 will be called as 2 factorial, making a symmetry. Okay, so if we want to make a symmetry in all of our series, and we know that series rules are saying that we can set a symmetry in our series. Okay, so this can be written as 2 factorial. So this can be written as 2 times 3 as 3 factorial. Fourth derivative can be written as 4th factorial, and continue in the same procedure. Means that if we are going to n derivative at the 0 place, so there will be n factorial in the denominator, that will be the nth coefficient. Okay, so collecting all these values means collecting all these coefficient values from here and using in our given term, this one, our function term, that one was equals to, I say that one was equals to f of x. I didn't write, let me write that. Over here or in the Suppose the last, anywhere you can write, okay? So use that for writing the value of all the coefficients. So f of x will turn to first term, that is f of 0 plus a1, that is f bar of 0 with the variable x, plus a2. A2 coefficient is f double bar, means second derivative at 0 over 2 factorial and x square, plus a3 third coefficient or fourth coefficient a3, that is triple derivative at 0 over 3 factorial, and x cube will be written here. Continue with this formation. Next coefficient is equals to fourth derivative at x0 over 4th factorial and x power same 4th. Continue in this way. Nth derivative at x0 over n factorial and x power n. That will yield the required coefficients. So this complete expansion is, it have a specific name. This is called Maclaurin series. Maclaurin series or Maclaurin series expansion. Normally we call it as Maclaurin series also. Okay, sometime we are calling it Maclaurin series, or sometime we are calling it as Maclaurin theorem. Okay, hopefully you understand this theorem. Let me revise it once again. What I have done, I have taken a series expansion of the function. Series can be of this form, and that is called the power series expansion of the function f of x. So if we want to find out the coefficients, we will specify the power series by finding the successive derivative of the power series. So we will evaluate all the derivative at x is equal to 0. I find out the successive derivatives of the series, then I put the value of x at 0 and find out their respective values. Then from the respective values, I turn the derivative to find out my coefficients in this form. Then I put the value of these coefficients in the given series and I get this required result. And this series is called Maclaurin series expansion or Maclaurin theorems. So thank you so much. Please like and share my video and subscribe to my channel. Allah Hafiz.